Hey, how you doing? It's good to see you. Thank you for being here. Today we're going to learn how to solve a system of linear equations using the best method, the elimination method. And, right here, I'm going to eliminate your burden of perfection. You need not be perfect here today. I trust me, I ain't going to be perfect, so you ain't got to be perfect neither. All right? You just got to try your best. So let's go with it and see how it works. I think you're going to be successful today. So a system of equations, is two equations, or three or four, whatever. But in this case, two equations and two unknowns. And you can't solve one equation with two unknowns. But you can solve two equations that got two unknowns. But you do that by combining them into a single equation that only has one unknown. So let's look at this really quickly. And we're going to do it by adding or subtracting. So one of the things I notice is that these values are different. So that's fine. I could eliminate them, but I'm going to keep going. We're going to look at my y values. They're the same. We've got 7y up top, 7y down below. So I know if I subtract the bottom equation from the top equation, that the y's are going to eliminate. So let's just do it. Okay, so minus 5y, take away positive 10. So if you're going to take away positivity, you're getting more negative. So we're going to end up with negative 15x plus, and because I'm such an artist, I'm going to draw a little cloud. I'm going to write poof to kind of indicate the elimination of the variable. There goes the y's. They went away. Because you got 7y minus 7y. And over here I got 40, take away 25. That's going to be 15. So negative 15x is equal to 15. Therefore, x is equal to negative 1. Yes! Are we done? I said, are we done yet? That's where you say, hell no, Mr. Miller. We ain't done. Because that's only one of the two variables. You see, we also got to solve for y. So here's what you do. You pick either equation, whichever equation you want to use. It doesn't matter. And you substitute in the x value back into that equation, and you see what you get. So I'm going to pick this one because I like that there's no... Oh, never mind. I'm going to pick this one because I like this negative times a negative being positive. So here's what I'm going to do. I'm going to rewrite it. All right. And now I'm going to solve for y. Well, let's go get it. Negative times a negative is positive, so I got 5 plus 7y is equal to 40. All right, all the way I already see that y is going to have to be 5, but let's keep going here. So let's subtract 5 from both sides. Gorgeous. Divide by 7. And there we go. Our final answer should be listed as a coordinate point. Negative 1, 5. And fundamentally, we have two lines. When two lines have the potential to intersect in one place, no places, or they have an infinite amount of intersections. All right. Well, it's time for you to try one. So let's put one more on the board. All right. Well, you know what I'm going to say? Pause the video and try it yourself. And do not forget that I have taken away the burden of perfection. Just give it your best shot, and I'm giving you a virtual hug for your effort. All right, so this one actually a little bit different as we approach this because these signs are different. I got a positive and a negative. Last time we subtracted. Now this time I'm thinking, well, damn. Actually, if I add these two equations, that's what's going to cause the elimination because now I get 4x plus negative. There is the poof. There goes one variable. We don't want to eliminate them both, right? So I'm happy that the second one's still there. So I got 10y plus, if you'd like to write the plus, is equal to 40. So y is equal to 4. Beautiful. It's going good. I told you it would. Oh, I rhymed. I knew that I should. All right. So now I know my y value. Am I done? Am I done? No. Hell no, Mr. Miller, you're not done. Because this equation has two variables for which you have solved for one of them. Congratulations. It's time to solve for the other. So I'm going to come up here and I'm going to pick the top equation because I like, in this case, that it's all positive. So let me write it on the board. All right, let's finish strong here. So I got 4x plus 32 is equal to 30. So 4x has to be equal to negative 2. And, right, because negative 2 plus 32 is 30. Therefore, x would have to be negative 2/4 or negative 1/2. All right. So in both equations, if you make x 1/2 and you make y 4, it should equal whatever it's supposed to equal. In the bottom one, it'll equal 10. The top one, it'll equal 30. You don't believe me out there? Just try it. That's how you check your answer. Yeah, let's check our answer. Hey, what the hell? We'll do it fast. And there we go. So you can check your answers and be like, hey, yo, teach, I know I got this one right because I checked my answer. And your teacher's going to be very proud of you. He'll be very happy that you did that. So, all right, let's get one more. I think we're in a groove. All right. Well, this one has a little bit of a twist because you should be asking yourself, like, I wonder how, how much more difficult can this get, right? And I think this is a decent example. So we look at it and we see right away that none of the values are the same or like a perfect opposites where we can either subtract or add our way to 0. I guess I forgot to ask you to pause, but I think you know the drill. You probably did if you wanted to. So now what I'm going to do is think to myself, okay, I actually have to use multiplication to scale one of these values so that they're either the same or they're like that perfect opposite, right? So I look at the x's and I see that this one, if I multiply by 3, that's going to set up the same value on the top and bottom, which means I'll be able to subtract. The y's, I could multiply that by 5, the top equation, and then multiply the bottom equation by 2, and that would get my y's to be the same, which I like. So I could do either one. There's a few ways to do this problem. I think what I'm going to do is just multiply the bottom by 3. So what I'm going to do is I'm just going to take this bottom equation and scale the whole damn thing by 3. Maybe negative 3. I'm going to do negative 3. That's going to allow me to add. And, I think students sometimes would prefer to add rather than subtract. So I'm going to multiply everything by negative 3. My new equation I'll write in blue. So this is going to become 9x instead, right? Negative 3 times negative 3 minus 15y, right, is equal to 15. So I'm going to put kind of a line through that one. I don't want to use that equation anymore. So now I'm set up really good here. I'm going to add. I don't know if I have a better color. Doesn't look like it. Maybe I'll just switch back to black. I'm going to add this top equation to the bottom equation. And remember, I don't know if I've said this yet, but you can do that because of the gorgeous sacred beauty of that equal sign. Remember in mathematics, you could do whatever the hell you want to an equation as long as you do the same thing to both sides to maintain balance. Well, because these two values are equal, if I add this to the left, I can add that to the right because they're equal to the same thing. So let's do it. Here we go. Where's my purple marker? Here's the poof. There's the elimination that we wanted. Poof. Gorgeous. Okay, so we got 2y plus negative 15 is going to bring us minus 13, right? And we have this addition here. Oh gosh. 65. That's 64, right? 64. And does 13 go into 64? Ay, 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 mamma mia. we have ourselves not the friendliest problem I've ever given you. Sorry about that. But it's going to be y is equal to 64 divided by negative 13. I was expecting some integer answers. Maybe I didn't, maybe I picked the wrong problem here, but that's what it is, and 13 is prime, so I'm not going to be able to simplify that at all. That's the y value, kind of messy. I have to plug that back in to solve for x. I don't feel like doing that, so I'm not, but I'm going to use this second equation here. You would go 9 times x minus 15 times 64 over negative 13. And yeah, not too interested in finishing that one, but I think the key that I hope you take from this is this first step, is really that elimination step, is that you can scale an equation to set up elimination. Sometimes you're going to have to do that, okay? Let me put on some music here. Okay. Hey, you know what? I just thought, even when I started the video, I said I didn't expect perfection from you. And I wasn't perfect. I gave you an example that had a weird fraction that I didn't want to have happen. So I guess I clearly was not perfect. Right? This, I think I've said it before, damn being human thing. Anyways, stay hip and be kind to each other, and I look forward to helping you in another video. All right, take care.